Welcome to ChemDoodle Shorts. I'm Mary, your ChemDoodle Pro. Let's learn about the periodic table. The periodic table is an important tool, often used in the sciences, particularly chemistry. Scientists can quickly access basic information and trends about chemical elements. To view the interactive periodic table in ChemDoodle, select the View menu. An interactive periodic table. The periodic table, or periodic table of elements, organizes the many chemical elements in order of increasing atomic number. An element is a pure substance that is made up of just one type of atom and cannot be broken down further by chemical reactions. Let's better understand the parts of the periodic table. The vertical columns are called groups. Starting on the left is group 1. The next column is group 2. The next column is 3, 4, 5, 6, 7, and so on to 18 on the far right. Elements in the same group or column exhibit similar chemical properties. They react with other elements in similar ways. The horizontal rows in the periodic table are called periods. Starting at the top, period 1 consists of hydrogen and helium. The next row is period 2 with 8 elements. Same with period 3. Period 4 has 18 elements. And numbering of the rows continues sequentially to period 7 at the bottom. Elements in the same period or row exhibit similar physical properties. Sometimes periodic tables are colored to indicate the different kinds of elements. Let's look at some of these blocks. Let's begin on the left side at group 1. All the elements in group 1, with the exception of hydrogen, are alkali metals. This includes lithium, sodium, and potassium, among others. These elements are soft, shiny metals that are extremely reactive. In fact, they are violently reactive with water. Due to their reactivity, they are not naturally found in a pure state, but rather found with other elements in nature. These alkali metals are in the same group, so they have similar chemical properties. Next to the alkali metals are the alkaline earth metals in group 2. Magnesium and calcium are among these. Alkaline earth metals are solid under normal conditions. They are not as reactive as the alkali metals, but are still very reactive that they are found in combination with other elements in nature. They are not found in a pure state. Alkaline earth metals are in the same column, group 2, so they exhibit similar chemical properties. The transition metals range from groups 3 to 12. Among them are titanium, iron, copper, silver, and gold. They are malleable and ductile, able to be fashioned into different forms, including sheets and wires. Like the alkali metals and the alkaline earth metals, the transition metals are solid at room temperature, with the exception of mercury, which is a liquid. Buried down between the alkaline earth metals and the transition metals is what appears to be empty space in the periodic table. These are the inner transition metals, or rare earth metals, the lanthanides and actinides. These elements are often pulled out from the periodic table so that the entire periodic table can better fit on paper or screens. Lanthanides in period 6 are soft silvery metals with similar chemical properties. Actinides are found in period 7 and include uranium. They are radioactive and include mostly man-made elements. Even more metals can be found in groups 13 through 16, including aluminum and tin. Metals have a metallic appearance, are malleable and ductile, and are good conductors of heat and electricity. As you can see, most elements are metals and are found on the left side of the periodic table. While there are numerous metals, there are also nonmetals. Some of these nonmetals are found in groups 13 through 16. They include the building blocks of life: carbon, nitrogen, oxygen, and even hydrogen from group 1. Unlike metals, nonmetals are brittle, not malleable as a solid. They are found in different states of matter. They are also poor conductors of heat and electricity. Moving further right in the periodic table is group 17, which consists of the halogens. Among them are fluorine, chlorine, bromine, and iodine. These nonmetals are very reactive, often very colorful, and extremely corrosive. On the far right of the periodic table are the noble gases in group 18. As you might guess from the name, these elements are colorless, odorless gases with very low reactivity. Some noble gases include helium, neon, argon, and xenon. Some periodic tables have a step line separating the metals and nonmetals. Elements to the left of the line are considered metals, except hydrogen, while elements to the right are nonmetals. Elements found along the line are considered metalloids, or semimetals. These can include boron, silicon, germanium, arsenic, antimony, tellurium. These elements exhibit properties in between that of metals and nonmetals. They are brittle and can be dull or shiny. They can conduct heat and electricity, but not as well as metals, and are often used as semiconductors. While we now understand the various colors, groups, periods, and blocks in the periodic table, there's still more. Each element is represented by a box called an element key. In this, there's a chemical symbol, which is 1 or 2 letters, that represents the element. C is the symbol for carbon. The element key also consists of the element's atomic number, or the number of protons in the nucleus. Carbon's atomic number is 6, which means there are 6 protons in its nucleus. Oftentimes, periodic tables also include the atomic mass, the mass of an atom of an element. Carbon has an atomic mass of 12.0106 AMU. While periodic tables can include much more information such as states of matter and other properties, the element symbol and atomic number are the basics. Thanks for watching ChemDoodle Shorts.